Hello problem solvers, welcome to another video. I had a question on the Maths Explained Discord to do with step preparation. And luckily for me, T-Formula jumped into the Discord as well and was helping out with that. And we've decided to do a bit of a collaboration together. So he's joined me in this video. Would you like to introduce yourself and talk a bit about your experience with university admissions and the Maths Challenge scene?
Yeah, hi Maths Explained. It's good to talk on here. Seen a lot of your work.
Thanks for joining me.
Yeah, you're doing a good job. Happy to be here.
Thank you.
So, I work at a UK university, so I definitely have seen a lot of this type of challenge and worked with a lot of students to help them get into universities that require this sort of challenge. I've been teaching maths for 12 years, so it's not always been at a university, and a full-on math challenge tutor for about 6 years. And I've got to tell you, these kind of questions, they're so much fun. They give me passion and reinvigorate my enthusiasm for teaching. There's weird questions, like, for example, if you're trying to get into Oxford, they ask you, what's your favorite number? And a lot of people fall prey to just saying, oh, 2, because, once I put 2 on the lottery and it got me a win. And that's great, but where's the maths? You've got to think a bit more clearly. Some people go for irrational number root 2 because of various reasons. And, it's important to Pythagoras' theorem, etc. But, really, what do you do with that? There's such strange questions. But it allows you to be almost write an essay of maths, which you're not used to doing. But you're not writing an essay in words, you're writing an essay in maths language. So it could be really fun, especially if you embrace it. And this kind of thing, though, preparation takes a long time. You can't just jump into it, really. It takes a quantum leap in the way that you think. So, these questions clearly are outside the box. And, you have to have confidence to do them. It goes without saying you need a baseline of understanding. But there are new skills that we will introduce to potential candidates so that they can tackle it. It's very different to the GCSE skills. You'll see a little hints of them, but, there'll be more. What do we do these for? I mean, some people do them for the fun of it. In fact, probably a lot of people do it for the fun of it. And you will have at the lower level, so you start around the age 12, unless you're prolific, you could start younger. Something like the UKMT, which is the UK Maths Challenge, or the Olympiads. So you have the junior, intermediate, etc. So those are for fun and practice and, esteem. And you could go to the international stage on those. And then further up, when you get to A level, so level 3, that would be, you have things that will prepare you for university, which are very much of the same ilk. You have the TMUA, T-M-U-A, and this is an admissions test, as well as STEP and MAT, MAT. And all of these are acronyms, and they're used and developed by different universities. The TMUA is done in November. It's pretty low stake, and it's quite fun in a way, because if you do badly or you do well, you don't need to admit it to the university. It's not on your final results sheet. So you can see that at the beginning of the year, see how you do. Use it as a practice, or maybe you do really well, and it can only bolster your application for a university. Some of you listening to this might not be going to university for a long time, and you might have been like me or like someone else at your age thinking, right, let me just, get through the next day or the next term. But if you can really think about what you want and think ahead, you have such an advantage. These things, they start, far in advance. So the UKMT leads on to these kind of tests, so that, you're prepared, because they are a different way of thinking. The STEP is...
And I just want to jump in. I do want to jump in there, because there might be some people watching who do have, their university kind of entrance test or whatever they're preparing in the near future. And maybe we're going to be doing something on that also in the future. But that won't be in this video.
Yeah, that's a good point.
Sorry for interrupting.
No, that's a great point, actually, because if you think about the Timua and STEP and MAT, they are for the end of the course. Timua is a bit earlier, but I was about to talk about the STEP in the MAT. They get done in the summer. So at the very last minute, you get your result, and actually they do get published. But the point you made, let's go back, because that is quite developed. And if you're just starting out to think about doing your STEP because you're just starting A-level in the September, you probably don't want to start at that high level. If you go on the website, you can see so many levels that you can start at, and they've got famous mathematicians as their names. My favorite's Emmy Noether. Those show you pathways, so you don't want to start on a pathway that's too high for you. So that's why the video we're making now, it's going to be more aimed at starting at the lower levels so that you can ease into those harder ones. The last thing is that, why would you need to have these admission tests? Why would you need to think ahead? Maybe sometimes you don't know you're going to study maths until you get there. I had one student one year who was adamant they were going to study law, and then when they were so enthusiastic about maths after learning it in my classroom that they ended up changing to maths. So it's not always, known, and it is quite a mature decision to say, right, I'm confident enough to take on maths. A lot of people find it intimidating. But if you are thinking of doing that, that's why you want to be doing these sort of tests, because at university, anything that's maths, engineering, physics, engineering is very popular right now, but anything that's highly numerate, you're going to probably need this to boost your application. If not, it's actually required at certain universities. For example, the STEP exam, that's actually designed and run by Cambridge, and they're the people that require it if you want to study maths there. The University of Warwick also used STEP, and so did Imperial London. So those are the ones that you have to have it for. And then there's others that you might just need it, to differentiate you from other candidates. So for example, King's, UCL, Bath, Lancaster, Bristol, or even Southampton. So there's thinking ahead is going to be the game changer for you here.
Okay, so today we're looking at an intermediate maths Olympiad question, which, as you said, is aimed more towards those students maybe starting out in that A-level course or think they might want to study at university and are curious about what steps they should take on that path. So if you want to give this question a go, you can pause the video now. Okay, so this question says, two squares are drawn inside a regular hexagon with side length 2. As shown, what is the area of the overlap of the two squares? And we get 5 choices here. Okay, so T formula, do you want to maybe say where we should start, or make a point about the difference between this question and a regular GCSE question, or however you want to get started?
Absolutely, yeah. Well, the first thing to note is that it is different from a GCSE because there's less structure. You'll notice that they don't give you much. The diagram isn't even partially filled out. And okay, you're given options, which some GCSEs give you. But a lot of it is about that first skill that you're going to have to start introducing into your repertoire if you want to do these questions, which is labeling things that you've not got particular labels for already. And with a question like this, my personal approach, where there's so little, is to write on the diagram as much as I can that it's given to me. And when I don't know the direction, absolutely write anything at all that I find is true about this question. So for me, this would start with knowing that this is a regular hexagon and that all of these sides are a length of 2.
Yeah. So just noticing that regular, when you see a regular 2-dimensional shape, that means, all the sides and all the angles are the same. That's a good initial thing to notice, I think. Good detail to point out.
But it doesn't give you much more. So we now need to think, what can we do?
Yeah, so my initial thought when I saw regular hexagon was I was thinking angles. That's where my mind goes.
There's not much else you can do, actually. You've labelled the sides, and it is in the GCSE spec to know about these things. So we should probably know the sum of the interior angles of a hexagon.
Or even just the formula, yeah.
720 degrees. So as a fact, but the formula, quick reminder.
And take 2 multiplied by 180.
Okay, that will give you this.
Beautiful. And if you want more detail on that, you can check out my video. And maybe T formula will have one in the near future. Or do you have one already on that?
No, not in this subject. I've decided to specialize in quadratics right now because I think that's the most important thing at GCSE.
Yeah, so if you want all things quadratics, check out T Formula's YouTube channel, where his videos focus on the sort of micro skills, I think. Would you say that? Or you really break it down, which I think is really great.
Yeah, I try to make the videos as succinct, and because you never know what part of the question that you need help on, and it's just, you watch them all, you get that great picture. Okay, so we're talking about these angles as the only thing we can think of, but what does 720 mean for us? I mean, personally, I would approach this and think, okay, well, let's label the right hand side and say, if there's 6 interior angles here, we could do 720 shared by 6, and each of those angles, as you can see there, are 120. I'm not sure where we're going with this, unless we think of another angle. I'm thinking personally, and this is part of the skill set of knowing beyond the GCSE, things perhaps that will help you and that are regularly used, and that when you're dealing with hexagons, you should often think about them as what should we say, a collection of equilateral triangles that go from the center. And then every equilateral triangle can be split down the middle to be right angled triangles. So if I just go ahead and drop a line in there, and we'll drop this line in right there, and that would ordinarily go to the center, but we can just stop at this point here because we do know about this angle here. It's going to be half of what was over here, so that's going to be 60 degrees.
Would you say the step up here is recognizing a link between looking for relating angles to lengths? It's a bit of a step up that you might not expect.
Absolutely.
In GCSEs.
Yeah, that's a good point, because we're thinking about the fact that hexagons, we should split them into equilaterals or right triangles, but at the same time, we don't really have any length. We go back to the question, the answers are all lengths, they're numbers, right? They're not angles. So we're now exploring and making our own links, because it's not going to tell us in the question. When my own link tells me, how do I relate all these 3 things? Angles, right triangles, and distances. And that for me screams trigonometry, right? And it is knowing and having that creativity to actually make those links. And therefore we just write down anything that might, nudge us, SOHCAHTOA, for example. These questions aren't designed for you to know straight away where to go, but you see what's happened after we write down a few things and we get to grips with what we do know about the question. We get new ideas, and it gives us more direction. I'm personally feeling optimistic because I can see ahead a bit here, but where do we go next?
Yeah, so I think there'll be some people watching depending on their level, will see a right triangle and they'll see an angle of 60 and they'll immediately make a connection. What about those that might not immediately see? What could they do to explore that right triangle there with the angle of 60 and a side of 2? What? I mean, I guess I would be tempted just to fill out that right triangle, and then find the side lengths.
Well, that's the first step there, right, having the 90 degrees. That means, by basic subtraction, that this must be 30. It's actually a very famous triangle, this one, 30, 60, 90. And now we've got enough information. We've got one of the sides, we've got the hypotenuses too. And we have enough information to start using trigonometry. Whether it's useful for us is the next question. So if I change color to something, we could drop a line in there. I'm going to think about whether this is useful. So this green line here represents what we could find out about this triangle, or we could find that bottom line there. I think considering that we're looking at these squares in the middle, that this green line on the right would be better than the one on the left. So I'm just going to go ahead and get rid of that one here. I note that that green line, I'm just going to draw a dotted line through the middle. I note that that green line stops halfway between the two.
Yeah, and if we zoom out for a second, go back to the question, I guess the initial problem, if you just immediately look to this question and you kind of trace these squares out, and let me see if I can do this accurately. If you just trace the squares out, you might be stuck. You might be thinking, okay, we know this length is 2, and then we're kind of stuck with, well, how do I find the height of this rectangle here, or the width? And there's no information. But now now maybe if we'd thought about that initially, or we kind of go back to the question, we can start making a connection and maybe find out that mysterious length that we need.
Yeah. So we're looking at that actually as 2, and there's a little part of it that we actually know. If I fill in this top one, voila, and I do it in purple, then we can see a bit clearer our triangle that we were looking at earlier. And the length, which is barely, we can barely see it now, it was in green, of the right hand side is something to do with that purple square. And if we knew what this length was, and I will just label it, I'll just draw it in. If we knew what that length was, and we know that the entire length here is 2, I think there's a case to be made for finding this little gap here. So if we label the length that we're interested in something like, say, y, just so we can focus on it, that let's use a bit of trigonometry to do that. We can see that y would be the opposite if 60 was the angle that we're focusing on. So we can use the idea of the sine part of trigonometry and say that sine of 60 is equal to the opposite, which is what we want to know, divided by the hypotenuse. Rearrange that, and we get 2 sine 60 is equal to y.
And sine 60 is actually, I think it's in the higher specification that students do need to know the exact value of that.
Some of the values obviously are useful to remember. So if you have angles 30, 60, 45, and you know that they have exact values if you're mixing them with sine, tan, or cosine. And so the sine 60 turns into root 3 over 2. And you can see the 2's cancel so that we have root 3. That's really useful to label back on our diagram. And if I just put that on the diagram, we've got root 3 up there. Okay, so it's looking good. Let me clear a lot of our board space for a second, and then we can work for the final bit. Final bit saying that we have a total distance of 2. We're able to find that little distance we've labelled x here. We could say that 2 subtract root 3. Hold on. This is looking good, actually, looking at some of the answers. Anyway, looking too far ahead, but sometimes it's good, I think, when you're given these questions that are very open, to just, when you're getting somewhere, look back to what you're trying to find. It gives you some confidence towards the end anyway. So 2 subtract the root 3 is the x that we're looking for. And this x is only half of that overlap. So we're really looking for 2x. So 2x is going to be 2 lots of what we had before. We can say that this 2x, may as well write that as the overlap. And here's another tip for you. I would definitely label what you have in words as you go along, so you have some context to what you have. And then you could think about what that is. If you've got random numbers, it's harder to understand the direction. And look, this is one of the answers already. So it's very easy to think, oh wow, look, that's one of the answers, and I'm just going to circle it and it's correct. But if we look back here, we're looking for the area. And as I know, it's very easy to fall into the trap of thinking you've found the answer. So in this, so in this case, this is simply the side of a rectangle. If I draw on really quickly, we have the side of a rectangle, which is what we have here. And to find the total area, we're going to multiply it by the length of that rectangle. So we're going to multiply that again by 2, like expand 2. So we end up with 8 subtract 4 root 3, and that gives us our actual answer there.
Awesome. All right, that was really informative, and I think just showed sort of the step up that that I guess is required if you want to take that pathway towards, you know, the kind of maybe the competition maths or the Tumua step mat, these types of tests. Just the lateral thinking required and the difference between, you know, GCSEs, A levels, and those type of tests. So thanks for sharing your expertise. Was there any other point you wanted to make about, you know, what people could do to kind of like get into it, or like where could they start maybe?
Yeah, absolutely. So we'll probably just say on the back of the question we just did that I hope that seeing that means that it feels more approachable, because sometimes it happens in any level of maths that you do. You end up looking at a question and feeling like this unconquerable wall that you have to get over because there's so many routes you can go, and you get overwhelmed and you think, no, that's not for me, I just don't have a go. If this kind of thing is something that you enjoyed, or it's something that you want to learn more about, because there's a whole community and you can enter competitions, you can advance and even do it for fun. Yes, there are prizes. Yes, there's esteem, and you can learn more. I've created a lovely poster document with links to everything for the coming year for the UK maths challenges that we have that will lead on to the Olympiads and training camps, etc. And it's all very exciting stuff when you get into it. So if you weren't interested separately in the Olympiads, it still prepares you for entering university.
This poster you've created is actually quite amazing. Kind of I haven't seen something like this before. No one's kind of aggregated this information together. I think it's a really useful resource. If there are any teachers watching, maybe not, but if there are, I would really highly recommend like maybe getting this printed out and putting it in a classroom or something, because I know as a student myself, I would have liked to have seen something like this. So well done to you for putting this together.
Very kind, thank you.
And I think it was a lot of work. It looks like a lot of work.
Yeah, it was many hours, but I think it's super useful. And as I said, there are hyperlinks on there. So it's not just that resource, it will be the gateway to all of the websites that provide you with resources and information. But I've tried to summarize it. You could use it as a poster. I've got it as an SVG file in a PDF, or it could just be for personal use. If you are interested in getting this resource, I'm giving it away absolutely free, and you can find it in the description of the video, which is equivalent to this one on my channel, which is the T Formula channel on YouTube.
So I would highly recommend heading over there, subscribing, because you make excellent maths videos.
Very kind.
And also amazing resources like this one. So yeah, for sure, to get this one, and I'm sure there'll be more to come in the future. Also Instagram and TikTok, which I don't have, but well done on that. Alrighty, so is that about it?
I think that's it for now. More to come.
Yeah, thanks so much for doing this collab with me. I've really enjoyed it, and then yeah, maybe we'll do something else in the future too.
Yeah, I look forward to it.
All right, thanks.
Thank you.